In the last class, I showed you how to construct an instance of your class using this technique, and this is sometimes referred to as creating a solid object. My time is a solid object of time, and what we mean by solid object is it's as opposed to a pointer to a time class. Okay, so another fact of creating objects this way is that they also get created in a section of memory called the heap. I'm sorry, the stack. Get my terms right. So the stack is, you can think of it as more temporary memory. When you're in a function and that function exits, the memory associated with the stack goes away. It all gets recycled. So sometimes you want things that live longer. You want to call a function, have it create an object, return the pointer to that object, but you don't want the object to go away. So what you need to do is you need to create that object on what's known as the heap or the free store. And so the way you do that is just slightly different semantics. So you create a variable and you make a pointer to it, okay, and give it a name. We'll say my new time. Then you use the equals operator and then the new keyword. The new keyword is the part that's saying, hey, go get me some memory off the heap. And then you use the class you want to create and then the standard constructor syntax. So that will just say time units, and let's say millisecond, like that. Okay. And that'll get us a pointer to a time object. So now there's one new little wrinkle, and that is, and I love Eclipse because you don't use the dot operator anymore. And if you type slowly enough and you hit the dot operator, Eclipse sees it and changes it to the new dereference dot operator. And so now this is how you get to all your public public methods on the class. Okay. So this operator is really doing two things. You can do this by hand if you want. So I'm just going to show it to you so you know, because it's what we learned in the other classes. You can use, it's dereferencing the pointer, my new time, like that. Okay, and then it's doing the dot operator. Okay, so you can see everything. This will do the same thing, but it's more convenient and faster, and you'll see it all the time. You're going to see that. Okay, so if we want to do something with that, let's just go ahead and see out that. And that's in milliseconds, so I'm just going to grab this too and throw that there. We'll compile that and we'll run. Okay, so everything's still good. There's our new 1 millisecond after the I'm helpful. That's our message right there. Okay, so let's take a brief look at the stack versus the heap. So here's one possible example memory map. I'm not saying this is how your machine actually allocates memory, but it's good enough for explanatory purposes. So some section of memory will hold your program code, and then any global variables if you have them, and then possibly on top of that will be your heap, and it typically will grow in one direction. So things that are asked for here can live a long time. Okay, and then then in another section of memory is your stack. So sometimes that's up at the top of memory and it grows down. So as you call more and more functions, nested functions, you're 10 or 11 layers deep, your stack's getting real big, you're here, and then as all those functions return, all this memory automatically gets returned to you. That does not happen here. And of course, if your stack runs into your heap, then you've basically run into an out of memory condition. So let's go back, because there's one thing we didn't do in the class, and that is we're in main, so when main ends, everything's going to get cleaned up anyway. But the rule in C++ is that anytime you use new, you have to marry that with a corresponding use of delete. You are responsible for returning that memory. So at some point, you really, in a good, well-written program, you would delete the variable you created like that. And the only wrinkle here is there's two forms of new. One is what we just did here, where we created a single object. There's also an array form. So when you use the new array form, that there's also a corresponding delete array form. So we're not going to get into that, but just remember that if you use it. But to tell you the truth, in modern C++, you really never have to use new and delete. There are other ways to create objects this way. Since we're on the robot, I'm not going to talk about those right now. I'm going to get to them in a later lesson, some of the new facilities. But if you move on to other types of programming and you're using the C++11, keep in mind that you don't really ever need to manually manage memory yourself anymore. The new facilities will do it for you. All right, that's enough for this lesson.